Okay, we'll start then, since more people have arrived now. So let's try this problem. Now, each day for 4 days, Linda travels for 1 hour at a speed that resulted in her traveling 1 mile in an integer number of minutes. Each day after the first, her speed decreased so that the number of minutes to travel 1 mile increased by 5 minutes over the preceding day. Each of the 4 days, her distance traveled was also an integer number of miles. What was the total number of miles for the 4 trips? So what are we given here? Well, we're given that the amount of time it takes to travel 1 mile is an integer number of minutes. And she travels for 1 hour every single day. So let's just call it 60 minutes since we're dealing with minutes here. So 60 minutes every day. And each time she travels in 1 mile in an integer number of minutes. So let's just call however many minutes m. So 60 over m will be how many miles she traveled on the first day. Because 60 is the total minutes and m is the number of minutes it takes to travel 1 mile. So then the next day, it's going to be 60 over m plus 5. The reason being, the next day, she travels 5 minutes faster, as you can see here. So her speed increases, the number of minutes to travel is going to become m plus 5. So m plus 5. And then the next one is just going to be 60 over m plus 10. Same thing, we just add 5 to the previous value. And for the final day, it's just going to be 60 over m plus 15. And we're given that the number of miles each day is integer. So basically, we're given that all these values are all going to be integers. Because we're given the problem that she travels an integer number of miles every day. So basically, she's decreasing her speed, and that's causing her to take 5 more minutes every single day. So now, let's try to find what values could be possible for m plus 5, m plus 10, etc. So in order to do this, let's look at the factors of 60. So we have 60. The factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that's it. And we see that we have to find 4 values that each have a difference of 5 between them. So we have to find 4 values that each have a distance of 5 between them. So we can see that the only possible values are 5, 10, 15, and 20. Because these are the only values that are separated by 5 minutes. So therefore, we must have m equal to 5, so this is 5. And m plus 5 will then be 10. M plus 10 will be 15. And m plus 15 is just going to be 20. And these are all integers. And we can just evaluate this. 60 divided by 5 is 12. 60 divided by 10, well, 60 divided by 10 is just 6. 60 divided by 15 is 4. And 60 divided by 20 is 3. And we can add this up and we get an answer of 25. Any questions?
So basically, because the denominator was increasing by 5, the number of miles was decreasing, right?
Yeah. So basically, the denominator kept increasing by 5, and that means that it takes longer to travel 1 mile. And since it takes longer to travel a mile, she's essentially going at a slower pace. And since she's going at a slower pace, she can't cover as many miles in that same 1 hour every single day. Any other questions? If there are no questions, we'll start the homework review then. So number 1 was, I am thinking of 3 integers. Added 2 at a time, their sums are 37, 41, and 44. What is the product of the 3 integers? So we have a condition here, so let's try and see if we can write an equation based on them. So the equation we can write is that, let's just say that x plus y is equal to 37. So before, I should mention that our 3 integers are going to be x, y, and z. So now, added 2 at a time, we have that x plus y is 37, and then we have x plus z is equal to 41, and y plus z is equal to 44. So what do we notice from these equations over here? We can see that x appears twice. We see that x appears twice, y appears twice, and in addition, z appears twice. So since we have all these values, we see that it's somewhat symmetric. So why don't we just add all of them up and see what we get? So we can just add all these equations. So if we add them up, we get that 2 times x plus y plus z is equal to 37 plus 41 plus 44. And we can find that 37 plus 41 is 78. 78 plus 44. Well, 78 plus 44 is just going to be 122. And then we can divide by 2 to both sides, and we get that x plus y plus z equals 61. So now we're asked to find the product. So how can we do this? Well, the easiest way would be to see that, okay, so now we have the value of x plus y plus z. So let's do x plus y plus z minus x plus y. And we get the value of z from here. And we can just do this. 61 minus 37. So z is 24. And now we can do the same thing to the other equations. So we have x plus y plus z minus, well, x plus z, which is equal to y. And this is just going to be equal to 61 minus 41. And we get that we can just subtract this out and we get 20. So y is 20. And now for x, do the same thing again. X plus y plus z minus y plus z. So x plus y plus z is 61. Y plus z is 44. So we subtract that and we get 17. So now I'll just multiply them. So we can do 17 times 20 times 24. And this gives us 1120. Any questions? We'll move on. Carl has a jar of jelly beans. He eats 1/3 of the jelly beans in the jar. Then he gives 10 of the remaining jelly beans to his friend. And then he gives 6/7 of them.
Actually, I just had a quick clarification for the previous problem. For the previous problem, I actually got 8,160. I might be wrong, but I'm not sure if 1,000.
Sorry, I was, yeah, this is wrong actually. I think I was referring to the previous, some other problem that had an answer of 1120. So sorry about that. Okay, so then we'll continue with homework. So Carl has a jar of jelly beans. He eats 1/3 of the jelly beans in the jar, and then he gives 10 of the remaining jelly beans to his friend, and then he gives 6/7 of them to his brother, and is left with 2 jelly beans. So how many jelly beans does he have at the beginning? So let's call the number of jelly beans he has in the beginning J. He eats 1/3 of them. So just like earlier, we had a very similar problem last class. We could write an equation and solve it, but let's go backwards instead. So if he eats 1/3 of them, he's left with 2/3 of them because 1/3 of them go away. So we're multiplying by 2/3 here. And then after that, we subtract 10 because he gives 10 of the remaining jelly beans to his friend. And after that, he gives 6/7 of the remaining jelly beans to his brother, or multiplies by 1/7. And then he's left with 2. So again, let's go backwards. So we know that 2, the inverse operation of times multiplication is division. So let's go in reverse. So we can do 2 divided by 1/7 or times 7. We get 14. And we can do 14 instead of negative 10. We can add 10 and get 24. And instead of multiplying by 2/3, let's divide by 2/3 or multiply by 3/2 and get 36. So that means J is equal to 36. So he has 36 jelly beans at the beginning. So we'll move on to the next problem. Suppose that A star B means 3A minus B. what's the value of x if 2 star 5 star x is equal to 1? So what do we do here? So here, let's just figure out and see if we can try to find what the value of x that will actually work here is going to be. So let's just evaluate this beginning expression here, 5 star x. So 5 star x is equal to 3 times 5. 3 times 5 minus x, which is equal to 15 minus x. Now all we have to do is 2 star 15 minus x. So 2 star 15 minus x, that would be 3 times 2, or 6. And then we would subtract b, or 15 minus x. This gives us 6 minus 15, which is negative 9, and negative x, which is x. So we can simplify this and we get x minus 9. And we're given that this is equal to 1. So that means we must have x is equal to 10. And there's actually something we can do here. Even though this is our answer, something we can do to check our work. We can put the value back in the problem to see if it actually works. And that can sometimes help check our work and maybe make sure our answer is actually correct. And this is a strategy that can be applied in many problems, like even this one, for example. We could see, okay, we could just apply the process of 36 jelly beans and see if we're actually left with 2. So that's a good strategy on these types of algebraic problems, because then we can essentially make sure our answer is correct, and it doesn't take too long either. So it's a good use of time to make sure you didn't make a mistake anywhere. So then let's go back here. So we could plug in 10 back into the problem. So then we would get 5 star 10, and 5 star 10 would be 5, and 2 star 5 would be 1, because 2 times 3 is 6, and 6 minus 5 is 1. So we see that our answer is correct. So 10 is the correct answer. So then we'll move on to number 4. So before we start this problem, I just want to introduce this factorization that you need for this problem. And it's that we have a squared minus b squared is equal to a minus b times a plus b. And just to see why this works, I'll just take a small example. So we'll just use a equals 7 and b equal to 3. Then we would then have 7 squared minus 3 squared equal to 49 minus 9, which is 40. And we would have 7 plus 3, which is 10. 7 minus 3 times 7 minus 3, which is 4, which is also 40. So we can see that these are also equal. So therefore, we can see that why this is true. So we're going to use this factorization for this problem. So I'll just leave it in the bottom right-hand corner for you to refer to. So let's get started with this problem now. A store increased the original price of a shirt by a certain percent, and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, what percent of the price was increased and decreased? So just to be clear here, why it's not just going to be 100% over here, I'll just give an example. So let's say we have 100% at the beginning, and then we take away 20%, for example. So we essentially multiply by 80%. Actually, let me just explain it in a different way. Let's just say we have something that costs $100. And then now we're going to multiply by 80%. Because that's we're going to remove 20% or decrease the price by 20%. We get a value of 80. And now if we increase the price by 20%, we would get 80 times 120%. And what's 120% of 80? That's just going to be 5/4 of 80. And 5/4 of 80, well, we can just evaluate, sorry, it should be 6/5 of 80. And 6/5 of 80 is just 96. So you can see that our values differed. So 96 is not the same as 100. And the reason this is true, the reason that this is actually true, is because when we remove some percentage and then we increase it, the percent, or we do the opposite, if we increase it and then reduce it again, we're reducing the price from the increased price. So some of the stuff that we increased is additionally going to be decreased along with the original value. So that's why it's not always just going to be even. That's why it's not always going to be the same. So let's try the general case here. So let's just say we have something, that costs $P. Now we're increasing it by X%. Let's just say we increase it by X%. Then we're essentially going to multiply it by 1 which is just the original price, plus x over 100. And then after that, we reduce it by that same x%. So if you reduce it by x%, we're going to be multiplying by 1 minus x over 100. The reason we multiply is we're taking that percentage reduced off the increased price. And we can multiply this out. We get p times, and here's where the factorization comes into play. We have a plus b, and then we have a minus b here. So that's where the factorization comes into play. And that we can get that this is going to be 1 squared, or 1, minus x over 100 squared. And we can simplify this. We get p times 1 minus x squared over 10,000. So now we're given that this is going to be equal to 84% p. So that means we have that 1 minus x squared over 10,000 is equal to 84%. And this means that we have x squared over 10,000 is equal to 1 minus 84%, or 16%, which is just 16 over 100. And now what we can do is, maybe I shouldn't have expanded this out. I'll just leave in terms of 100 squared. So now what we can do is we can multiply by 100 to both sides. In doing so, we get x squared over 100 equal to 16. And now that we know that x squared over 100 is equal to 16, we know that x squared is 1600. This means that x is 40. So our answer is going to be 40. Just like earlier, we can actually double check our work. So let me just show that here, since it's a bit unclear why this 84% thing happens. So to say if you have something that costs $P, we multiply by 40, reduce by 40%. So we multiply by 60%. We increase by 40%. We multiply by 140%. And we can expand this out. We get P times 84%. We can simplify that. That's why it's true, because we're taking that increase over the decrease, or essentially we're taking it over the increased price. It increased first and then it decreased, so we're taking the decrease over the increased price. Now let's move on to number 5. So Bella begins to walk to her friend's Ella's house. So let's say Bella's here and Ella's here. At the same time, Ella begins to ride her bicycle towards Bella's house, and they each maintain a constant speed. However, Ella rides 5 times as fast as Bella walks. The distance between their houses is 2 miles. So we have something like this distance is 2 miles. And they each maintain a constant speed, yeah. So which is 10,560 feet. So let's just put that there. And then Bella covers 2.5 feet with each step. So we're asked to find how many steps will Bella take by the time she meets Ella. So here's the thing that we must notice. So we see that Ella will ride 5 times as fast. So with a velocity of, let's just say 5v. And Bella will ride with a velocity of just v. So when they meet, they're going to meet something like here, let's just say. They meet here, that's, for example. This distance is going to be 1/5 this distance. The reason being, when they meet, Bella will be 1/5 as fast. So Bella will travel 1/5 the distance. So let's just say this distance is going to be x, this will be 5x. And this essentially means that the distance of the total, so we have that distance Bella travels to distance Ella travels, is just going to be 1/5. So now the distance that Bella travels relative to the total distance traveled by both of them, this is just going to be 1/6. Because we see that x over the total, which is x plus 5x, is just going to be 1/6. So now we see that Bella travels 1/6 of the total distance between their houses. So Bella travels 1/6 times 10,000 560. And we can just quickly evaluate this by, we just do 10,560 divided by 1/6. And we can easily find that the travels, if you divide this out, we get that 1/6 of 10,560 is equal to, well, we can do, it's equal to 6,000 plus 4,000. So, 6,000 plus 4,560. So this is just going to be equal to, after doing all the calculations, we get 1,760. So this distance is 1,760 feet. And let's find out how many steps she took. So 1,760 divided by 2.5 or 2.5. And we can essentially simplify this by we multiply by 2 to both sides in order to get integers. So in order to get integers, we have like 3,520 over 5, which is equal to, we can evaluate this to get 704. So 704 steps Bella takes by the time she reaches Ella. So now we'll move on to number 6. So this is a really interesting problem because it's phrased in an interesting manner. So I'll go over to the solution. So in a jar of red, green, and blue marbles, all but 6 are red, all but 8 are green, and all but 4 are blue. How many marbles are in the jar? So we have that all term. We see that, okay, we have all. So we see this all word appear so many times. So why don't we define a variable to be the total number of marbles? So let's just say that T is equal to the total number of marbles in the jar. Now let's write some equations, see if we can make any meaning out of them. All but 6 are red. So that means we have red equal to the total minus 6. All but 8 are green. So green equal to the total minus 8. And all but 4 are blue. So blue equal to the total minus 4. So now we have 3 equations. So now what can we do from here? Well, we can see that the total is just the number of red marbles, green marbles, and blue marbles. So we can see that the total, just T, is equal to R plus G plus B. So it's going to be T minus 6 plus T minus 8 plus T minus 4. And if we can simplify this, we have that this is equal to 3T minus 18. So T is equal to 3T minus 18. So now we can simplify this equation to get 2T equal to 18. We essentially add 18 to both sides, and then we can just move around some terms to get this expression. And we divide by 2, we get T equal to 9. So there are 9 total marbles in the jar. So this is a really interesting problem in the way that we got really nice that we can just add all these up and we get T. So now we're left with one variable equation, even though it seems super complicated at first. That's why this problem is really interesting. So before we move on to today's topic, any questions on the homework?
How did you get 2T from 3T?
So, okay, so we can just add 18 to both sides. So if we add 18 to both sides, we get T plus 18 equal to 3T. And we can subtract T from both sides. We get 18 equal to 2T. That's how we got it.
Oh, thank you.
Any other questions on any of the problems? Because if there's no questions, we'll move on to today's topic. So the first topic that we're going to cover today is mean, median, and mode, which you're probably mostly all familiar with. So I'll quickly go over this as a quick review. So the mean is the average of all the numbers in a list. The mode is the most common number, and the median, after arranging the numbers in increasing or decreasing order, the median is either going to be the middle number in the list or the average of the 2 middle numbers, if there's an even number of numbers in the list. So let's just basically try this really easy problem with mean, median, and mode. And even though this seems like an easy concept, AMC can give some tricky problems with this concept, which we'll get to in some time. So let's try this problem. Here's a list of numbers. Here's a list of the numbers of fish Tyler caught in 9 outings last summer. 2, 0, 1, 3, 0, 3, 3, 1, 2. What is the ordering of the mean, median, and mode of the number of fish caught? So in general, whenever we're trying to solve these problems, it's always best to order the list from least to greatest. So we can just do this. We see that there are 2 zeros, so 0, comma 0. And now there's going to be, there's going to be 2 1s. And then after that, there's going to be 1, 2 2s again. And then there's going to be 3 3s. And a good way to check that we got all the elements in the right order, you can just see, okay, we see that we have 9 elements, and there are indeed 9 elements in our list. So we make sure we order them correctly. So now let's find the mean, median, and mode. The mode is obviously 3, since there are 3 3s and only 2 of the other elements. So mode equal to 3. Now mean. So the mean is just the average. So we can see the total sum of all the numbers. The sum of all the numbers is just going to be 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 3. And we can divide by 9 numbers. We get 15 over 9, which is 5/3. So we have that mean is equal to 5/3. And now we're left to find the median. So there are 9 numbers in the list. So the median is going to be the 5th one, because now that we have it ordered, so in increasing or decreasing order. And this is in increasing order, so we're good. So it's just going to be the 5th element, which is going to be this 2 here. So that means we have median equal to 2. So now the ordering is that now we can very easily see that the mean is going to be the least, and we can see that the mode is going to be the greatest. So the ordering is going to be mean, median, mode. Any questions on this problem? If there are no questions, I'll move on. So let's try a very similar problem. Hammy is in the 6th grade and weighs 106 pounds. Her quadruplet sisters are tiny babies and weigh 5, 5, 6, and 8 pounds. Which is greater, the average or mean weight of these 5 children, or the median weight, and by how many pounds? So we have that Hammy weighs 106 pounds. So let's find the mean, median, and mode from these numbers. So first, let's order them from least to greatest. We get 5, comma 5, 6, and 8. Those are the quadruplets, and then 106. So we can very easily see from right away that 6 is a median. So median equal to 6. Now what about the mean? The mean is just the average. So 5 plus 5 plus 6 plus 8 is 106 divided by 5. And if we can sum this up, we very easily sum this up and we get that's 130 over 5, which is 26. So the mean is 26. And now we can clearly see that the mean is greater by 20 pounds. So mean by 20. Any questions? So if there are no questions, we're not going to go into some more challenging problems with mean, median, and mode. So now let's try a graph problem. The following bar graph represents the length of the names of the 19 people. what is the median length of these names? So if you remember from earlier, median is the middle when sorted from least to greatest. So we have 19 people. So the mean is just going to be the 10th. The median is going to be the 10th person when sorted from least to greatest. So we can easily see that there are 7 people that have 3 letters in their name. And then there are 3 people that have 4 letters in their name. So therefore we have that 7 people here, and then this is going to be like the 8th, the 9th, and the 10th. So therefore the 10th person is going to also have 4 letters. So the median is just 4. Any questions? Oh, I think I should add a clarification here. The reason that there are 19 people have a median of the 10th person is going to be the median of the 19 people is because if you list it all out from 1 to 19, the first, second, third person all the way till the 19th person, we see that the middle is just going to be the 10th one because the distance between the first and 19th person is going to be equal. So it's going to be like the distance between 1 and 10 is 9. And the distance between 10 and 19 is plus 9 too. So we have the 10 is going to be the middle of 1 and 19 to the bounds, like the first person, the 19th person. So that's why if you're wondering, that 10th is the middle person. So any questions then? No questions? Now we're going to move on. So here's another, this is a little bit more tricky problem. The mean, median, and unique mode. So before I move on, I just want to say that a list can have multiple modes. Let's say you have like 2 and 3 that both appear twice. But when it says unique mode, that means there's only one mode. Basically, there has to be one element that appears more than that times. So let's continue then. Of the positive integers 3, 4, 5, 6, 6, 7, x are all equal. What is the value of x? So we're already lucky. They gave it to us sorted. So we have 3, 4, 5, 6, 6, 7, x. We don't really know where x is. It can be anything for all that we know right now. So now the unique mode. We see that 6 is the only digit that appears twice. So right now, if you ignore the x, 6 is the mode. But now what if, let's say we made the x a 3, for example. Then 3 and 6 would both be modes, because then 3 and 6 would both appear twice. But that would not work, because we have a condition that the unique mode. So we have a unique mode to our thing. So we can't have 2 3s, 2 7s, 2 4s, 2 5s, etc. So this can't be 3. X can't be 3. Or any of the other values that already appear. So therefore, x has to either be an integer that does not already appear on the list, or it could be 6 too. Since it was 6, the unique mode would still be 6. So it can still be anything that there. So now we're given that the unique mode. So from here, we can easily see that unique mode is obviously has to be 6. 6 is mode. We already found here. So if 6 is the mode, it's also going to be the median, or it's also going to be the mean. So back to our original set of numbers, we have that 3 plus 4 plus 5 plus 6 plus 6 plus 7 plus x over 7 is equal to 6. Now we can solve this. We get that 3 plus 4 plus 5 plus 6 plus 6 plus 7 plus x. Well, we can add it up and we get a value of 31 plus x equal to over 7 equal to 6. And simplifying, we get 31 plus x equal to 42. So x is equal to 11. Because we can just subtract 31 from both sides. So our answer is 11 then. And note that we didn't even use the condition that the median is equal to the mean and the mode. But if you wanted to, you could also, it would be a good check to make sure you got it right. You could just check, okay, is the median also going to be 6? And you would find out that it is indeed 6 as well. So that's another good check to the problem to make sure you got it right. So any questions on this problem then? Are you sure? If you raise your hand, you can talk, or you can put in the chat. So any questions on this problem? Okay, so I don't see any questions, so I'll move on then. Here's another graph problem. So the diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and median values, coach discovers that there were actually 21 participants on Wednesday. Which of the following statements describes the change in the mean and median after the correction? So let's look at this piece by piece. Let's first find the change in the mean. So we see that originally it was at 16, but now we essentially make it 21, so right here. So now we see that we make it 21. So now what can we do from here? So we see that it increased by 5 on one day, so plus 5 on one day. So now that we have plus 5 on one day, how much is the mean going to increase by? Or mean or average, typically, it's referred to as. So we have plus 5, it's going to be the average of all 5 days. So over 5, so overall we get a plus 1. So overall our mean increased by 1. So now we know that the mean has to increase by 1. So now we know that you can eliminate C, D, and E. So it don't have to either be A or B. So now let's look what's going to happen to the median. So now what's going to happen to the median? So what's going to happen to the median? Well, we can see that originally the median, before this change happened, the median was, well, we have that the lowest was Friday, from least to greatest, it was like 1 and 2. Well, these are equal, so it doesn't really matter. And then the median originally was Monday, because then we had that Thursday was greater, and Tuesday was even greater. So originally the mean was on Monday and was 20. So original median was 20. But now the median is going to change. So now instead, this is going to be a new ordering system that we have. Now instead, we're going to have the least is going to be Friday. Second least is actually going to be Monday instead of Wednesday, because now we have this additional 5. So second least is going to be Monday, and then after that, the third least is going to be the thing on Wednesday. And the fourth is going to be Thursday, and fifth is going to be Tuesday again. So therefore, the median is now going to be the new value of Wednesday, which is 21. So now the new median is 21. So the increase is 1. So we have a plus 1 increase to the median and a plus 1 increase to the mean. So our answer is B. Any questions? So now we're going to go, if there are no questions yet, we're now going to go with some even more tricky problems. So these are some of the harder mean, median, mode problems on the AMCA. So let's start off with this first example. One is the beverage bar sold 252 cans of soda to 100 customers. And every customer bought at least 1 can of soda. What is the maximum possible median number of cans of soda bought per customer on that day? So we have 100 customers, so that's a lot to deal with. So we have, let's just call it 1, 2, 3, 4, 100. Or actually, I'll just write some other terms, 49 and 50. 100. So now we're asked to find the maximum median. And everybody has to at least 1 can of soda. So the median is maximized when these two values are maximized, because the median is just the average of these two values, since these are the middle two values. So now we have to find the average of these two values, and we have to maximize it. So how can we do this? So now that we're trying to maximize this value, let's see what we can do from here. So if we're trying to maximize this value, we don't really care about the first 48. So the first 48, these can be as low as possible, because we want to make 49 and 50. Oh, and just to be clear, I should be clear here. I forgot to mention this. This is starting from least to greatest. So just to make sure to note on that. So we want to maximize 49 and 50, but then we must know that 51 to 100 is going to be greater than 49 and 50. So we'll get to that later. But for now, we know that we want to minimize 1 through 48. And we can do this by just letting, or sorry, this should be 50 and 51. 50 and 51. So sorry, we should minimize the first 49, and then we have to minimize the first 49. So how can we do this? So we have to minimize the first 49, so we can just let them all be 1. So let's say they all have 1 can. Because we don't really need them to have more than 1 can. Since if they had more than 1 can, that would make the number of cans that 50 through 100 people got, they would make that less. So let's just give 1 can to all of the first 49 people. So now how many cans do we have left? Well, we have 252 cans originally, and we lost 49 of them because we gave 1 can to each person, and we must have at least 1 can of soda. And we get 203. So now we have 203 cans to give to 50, 51, etc. to 100. We're again from least to greatest. So now we don't really care about the first 49 anymore. So now let's shift our focus to the last 51. So the last 51 numbers. So what can we do about these last 51 numbers? So let's see what we can do from here. So we must have 100 has to be greater than 99, which has to be greater than ... all the way till 50. So let's just say we gave 4 cans to everybody here. So if everybody had 4 cans, then how many cans would be used? Then we would use 4 cans times 51, which would be 204. So we see that this is not possible. So just to clarify, 50 to 51, these are the customer numbers, and it increased from least to greatest. So he's like sorted it from least to greatest, where 1 was the least and 100 was the greatest. So basically the least is the least number of cans bought, and not necessarily greater than. 1 and 2 could be equal, for example, that would be okay. It's just from least to greatest, and each of these has to be less than or equal to 3, less than or equal to 4, less than or equal to ... So just to be clear on that, make sure you get that part. And if you don't get the part, just feel free to ask about it. So back to this part over here.
I did have a question. The median is the middle number, or the average of the 2 middle numbers, right?
Yeah.
So why would we have to maximize all of the numbers from 50 to 100? Don't we just have to maximize 50 and 51 so that those 2 would be the highest?
Yeah, we have to maximize only 50 and 51, but we also have to have 52 greater than 51 and 53 greater than 52. So we can just think of these as like a section. The reason that we have to maximize this whole range is that we can't have 100 be 1 and then 50 be like 100, for example. That won't work because we're given that 100 has to be sorted from least to greatest. 100 is the most, 99 is the second most, so on. So we can't just make the 50 and 51 the largest. Since if this was like 100 and 100, for example, then 50 and 51 would be greater than 100. But we're going median is the average of the middle 2 numbers when sorted from least to greatest. So these are sorted from least to greatest, so 50 is less than 51, which is less than 52, which is less than 53, and so on, all the way till 100. So let's just say we give,
that makes sense now, thank you.
Okay, so essentially right here, we're trying to maximize 50 and 51. So we want to make these as close as possible now, right? We want to make all these 51 values as close as possible. So in order to make these values as close as possible, we want to make them all have like similar amount of cans. Since we can't have, as I explained just now, 50 can't have all the cans, 100 cans, and then 100 only would have like 1 can. That's not allowed, since 100 has to have more cans than 50. So let's try to make them as even as possible. And we can see that if all of them have 4 cans, we have 204 cans we must give out. But that's too much. That's too much. We only have 203 cans. So now how can we reduce it? Well, we have to reduce 50. We have to make 53. And the reason we can't make like 79, 3, for example, because we have 79 is greater than 50. So that's not allowed. So we have to reduce it to the smallest value. So we have to make it 3. And from here we can easily see the median is just 3 plus 4 by 2, which is 3.5. So I just want to explain on one point a little bit more. So the reason that this is the maximum case is this is a tricky problem, so don't feel bad to ask questions later. So let me just give a clarification a little bit here. Let's just say that 50 was 1 again, and then 51 was also 1. And then we could have like 100, and let's just say all the numbers from 50 to 99 are all 1. Then we would have 153 left. So 100 could be super large. It could be like a super large number, 153. So 100 could be like a super large number. But then we don't want that. We're trying to maximize 50 and 51. So we can't make 100 too large. 100 is like the largest, 1 is the smallest, but we want to make the ones from 1 to 49 really small, because we want to just save the cans we're going to give to the higher people. But now when we're giving to the higher people, we want to make it as even as possible. Since we have to give the higher people greater than or equal to the lower people, but we don't want to give all of them to the like 199, for example, because if we give all of them to 199, 1551 will become very small. And if 1551 are very small, the median is not the maximum. So that's what the reason that this is the maximum case. So any questions on this problem? And don't feel bad to ask questions because this is a very tricky problem. Okay, we'll move on if there are no questions. The mean of 5 different positive integers is 15. The median is 18. What's the maximum possible value of the largest of these 5 integers? So I'll give some time for you guys to work on this on your own. Actually, we're running out of time, so I'll just go through the problem actually. So we have 5 different numbers. The median is 18. The mean is 15. And the reason I marked the third value to be 18 is because the median of 5 numbers is just going to be the third number. So now, this is a very similar problem to the previous problem, except with smaller numbers. So we want to maximize the largest of the 5 integers. So we want to minimize the first 4. We want to find the maximum possible value of the largest of these integers. So we want to maximize this value, the 5th value, and minimize the first 4. So, but we have to have the third value be 18. And the 4th value, okay, just to be clear again, I've sorted them from least to greatest. This is the least, this is the greatest. So I just want to be clear on that. So we want to maximize the largest value and minimize the first 4 smaller values. So and we are also given that we have 5 different positive integers. So make sure to keep that in mind. So let's just minimize the first 2 integers. Let's just let it be 1. The second value, it can't be 1 since we have different integers. So let's just make it 2. And now what about the 4th value? The 4th value has to be greater than or equal to the 3rd value, but it can't be the same as the 3rd value since we have different positive integers. So the minimum is just going to be 19. And now we have the mean is 15. So if the mean is 15, the total sum of all the numbers is going to be 75. And then what is the last number going to be? 75 is the total sum, and we have 1 plus 2 plus 18 plus 19 plus x is equal to 75. And we can simplify this, we get x is 35, since this part is just 40. So the maximum value is 35. Any questions on this problem? Okay, we'll move on then. So let's go into this problem over here. This is a slightly different problem from the ones we've been doing earlier. The harmonic mean of a set of non-zero numbers is the reciprocal of the average of the reciprocals of the numbers. What is the harmonic mean of 1, 2, and 4? So the reciprocal of the average of the reciprocals. What is this even? It seems like a very complicated thing that we're trying to find here. So let's try to break it down and see what it actually means. So if you don't already know, the reciprocal basically means 1 over. So the reciprocal of 2 is 1 over 2. You didn't already know that. So the reciprocal of the average of the reciprocals. So first, before we even deal with the 1 over, what is the average of the reciprocals of the numbers? The average of the reciprocals of the numbers is going to be 1 over 1 plus 1 over 2 plus 1 over 4. These are the 3 numbers. And what's the average of the reciprocals of their numbers? It's going to be this quantity divided by 3. Okay, so let me just explain this a little bit more. So we have that this over here is going to be the average of the reciprocals of the numbers. Because the reciprocals are 1 over 1, 1 over 2, and 1 over 4. And the average is when you divide it by 3. And then we take the reciprocal of that. And then we can simplify this. So we know that we can simplify this and do some little bit of math here, algebra here. We get 3 over 1 over 1 plus 1 over 2 plus 1 over 4. This is equal to 3, 4 over 4 plus 2 over 4 plus 1 over 4, which is 3 over 7 over 4, which is equal to 12 over 7. Any questions on this problem? So just in general, here's the formula for harmonic means. So basically a1 through an is just going to be 1 over the average of all the reciprocals. And then if you simplify this, we get this expression here. So that's just in general for harmonic mean of n numbers. So we're going to move on to this next problem then. Now we're going to move on to telescoping. So let's try this basic example. What is the value of 4 times -1 plus 2 -3 plus 4 -5 plus 6 -7 plus 8 all the way to 1,000? So the idea of telescoping, before I jump into this problem, telescoping basically means mass cancellation. So just a lot of terms cancel and we're left with something nice. So there's almost no way we can actually add and subtract all these numbers. So before we try that, let's see if we can cancel some terms out. So we can rewrite this as 4 times 2 minus 1 plus 4 minus 3.
Wait, I just had a... Oh, wait, never mind. Sorry, I didn't read the question correctly.
Okay, so then move on. Okay, so 4 minus 3. So we're just taking these terms. 2 minus 1. We're just rearranging these terms. And 6 minus 5. And so on all the way till 1,000 minus 99. So does everybody see why this is true? We literally just flipped all these terms. So make sure you understand why this is true. We literally just rearranged this equation. And now you might notice that it's just going to be 4 times. This is 1, this is 1, this is 1, so on. This is also 1. So now we have that this is just going to be, so now we just have to find how many terms there are. So how many terms are there? Well, we see that there's just 500 terms. The reason that there are 500 terms in this is because we have all the even numbers, 2, 4, 6, 8, till 1,000. So we have all these even numbers, so it just comes to 1,000 divided by 2. It's 500. So we have 500 of these terms because we have 1,000 total terms. We have 1,000 total terms, and we grouped it into pairs of 2. So 500 of these ones, so 500 ones. And this is just 2,000. Any questions? So now we're going to see this idea in a similar problem. So we're gonna move on then because we're running out of time. So in this next problem, what is the value of the product 1 plus 1 over 1 times 1 plus 1 over 2 times 1 plus 1 over 3, so on all the way to 1 plus 1 over 6. So how can we make this? Again, we could just multiply this. It's not going to be that bad. I'm sure you all can do this. But is there a way to do this quickly? Since on the AMC, time is important, and you don't have that much time. So here's something we can try to manipulate from this equation. 1 plus 1 over 1 is just 2 over 1. 1 plus 1 over 2 is 3 over 2. So you guys are seeing what's happening here? So 1 plus 1 over 3 is going to be 4 over 3. And 5 over 4 is 1 plus 1 over 4. 6 over 5 is 1 plus 1 over 5. And 1 plus 1 over 6 is 7 over 6. So make sure you understand why. We just converted all these mixed fractions into improper fractions or common fractions. So now what do? We have to multiply these again. What can we do from here? Well, the 2's cancel, the 3's cancel, the 4's cancel, the 5's cancel, and the 6's cancel. So we're left with just 7 over 1, which is 7. And imagine how much easier this method is than expanding this out in the brute force manner. So this trick is really cool, and it can be used in even more complicated problems. So now we're going to move on to the last problem. So actually, before we move on, are there any questions on this problem? Or this technique in general, telescoping in general? So there are no questions, we'll move on to the next problem then. What's the value of the product? This is a slightly more tricky problem, so we'll try to break it down. So what's the value of the product? 1 over 2 times 3 over 2 times 2 over 3 times 4 over 3 times 3 over 4 times 5 over 4 dot 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 all the way till 97 times 99 over 98 times 98 times 98 times 100 over 99 times 99. So the key to this problem is using a similar approach, except here it's not that simple. So here's the hint on how you can do this problem. We can just take the 1/2 term, 2/3 term, 3/4 term, and all these left terms and group them together. This will give us 1/2 times 2/3 times 3/4 times dot 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 all the way till 98 over 99. And now we can group the green terms that I'm marking. This gives us 3 over 2 times 4 over 3 times 5 over 4 times 6 over 5 dot 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 all the way till times 100 over 99. See if you can try solving this problem on your own. So I'll give some time to try to see if you can solve this problem. So the trick is evaluating each of these expressions and then just multiplying them together. So now I'm going to go into the solution. So the trick here is the 2's cancel, the 3's cancel, the 4's cancel, the 5's cancel, so on, the 98's cancel, and we're left with 1 over 99. Now the second expression here, we have that the 3's cancel, the 4's cancel, the 5's cancel, the 6's cancel, dot to dot, all the way till the 99's cancel. And this gives us left with 100 over 2, which is just 50. So the product of these is just going to be 50 times 1 over 99, which is 50 over 99. This is actually a problem. This is another very interesting problem too. So any questions on this problem? Okay, so it looks like we're out of time. Oh, we got this other, but let's go over this one question then actually. So what is the value of this expression 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 divided by 1 plus 2 plus 3 plus 4 all the way till 8. So 1 times 2 times 3 times 4 divided by, so this bottom part over here, we can just manually add it up for now. You can manually add it up and get 36. And in a future class, I might go over a quick trick to doing this much faster. But for now, it's okay since it's just 8 numbers and you can very easily add it up. And now we can just cancel some terms here. So you can see that 36 cancels with 6 to get 6 here on the here. And now 6, well, 6 is just equal to 1 times 2 times 3, or 3 factorial. So that cancels out. So we're left with 4 times 5 times 7 times 8, or 20 times 56, which is 1120. Any questions on this problem? Okay, so if there are no questions, and that's it for today. So just like usual, I'll send the homework problems, just like usual. And I made the homework a lot easier than last time based on the feedback. So this week, the homework should be a lot easier than usual. So try the homework the best, and thank you for coming, everybody. Bye, and see you next class.